So question 15, a cream is sold in a 34-gram container. The average amount of cream used per application is 1 and 8/9 grams. So how many applications can be made with the container? So this problem here can be a little tricky because the 1 and 8/9 is kind of foreign to me. So what in the heck does 1 8/9 mean? Well, I know that 8/9 is close to a whole, so that's really 1 and 8/9 is really, really close to 2. So if I'm using estimation, we're saying each application takes approximately 2 grams. So if I have a 34 container, how many times can I apply 2 grams? So in other words, you could be adding how many, you could be asking yourself, how many twos does it take to get 34? That sounds like division. How many twos does it take to get 34? So how many twos does it take to get 34? Well, if you use long division, 2 goes in 3 one time. 1 times 2 is 2. Subtract the remainder of 1 and bring the 4 down. And how many twos go into 14 would be 7. 7 times 2 is 14 with a remainder of 0. So in other words, half of 34 would be 17. So this would tell us that it's going to be approximately 17 applications can be used. Now, what we pick up on is, 34 divided by 2 is really written as 34 divided by 2. Now, to get the exact answer, though, I have to be using the 1 and 8/9. So this really means 34 divided by 1 and 8/9. Now, what you can do is change 8/9 into a fraction. 34 divided by, well, how many ninths are there? Remember, 1 means 9/9. So 9/9 plus 8 more ninths is 17/9. Now, remember, the shortcut is just multiply the 9 times the 1. That tells you how many ninths are in 1. 9 times 1 is 9, plus 8 would be 17, and then just keep it as 17 over 9. So remember, in math, we actually don't divide fractions. We actually, well, we use the phrase Kentucky chicken fry, which means to keep, change, and flip. That's our little strategy we use. So Kentucky chicken fry, or keep, change, flip, if you will. So what that means to do is keep the 34, change the division problem to a multiplication problem. But do that, you have to take the reciprocal of the 17/9, which means to flip it. So that's 9 over 17. So if I do the math, notice that you can write this as 34 over 1 times 9 over 17. And remember, if you have a like factor, you can cancel that out. Notice that 17 does go into 34 twice. We just kind of did some math up there, actually. So I can actually cancel out the 17, turn into 1, because 17 divided by 17 is 1. But if I divide the 17 by 1, I have to divide the 34 by a 17 as well. And 34 divided by 17 would be a 2. So 2 times 9 would be 18 applications. So that's what the math would look like if I was doing it by hand. And that should make sense because we rounded up. So we should actually get more applications than 17. So we get actually one more application. So estimation gets us in the ballpark, but this is the actual math to get the 18 applications. Now, notice on your calculator, you can just actually type in 34 divided by 1 8/9. If you understand, that's all you really got to do. So if I clear this all off here, I could type in this, let me see if I can get this clear off here. So 34, if I divide that by, notice how 1 and 8/9 is a mixed number. So if I hit the alpha button and hit the F1, notice that number 2 is a mixed number format. And I may want to put this in parentheses too. I'm not really sure how this all looks here. Well, let's see what it does without parentheses. So let's choose number 2. And let's see if it'll type in this 1 and 8/9 here. 1 arrow 8 arrow 9 come out. Let's see if it actually does that math correctly. So notice how I did put the parentheses in for us. So 34 divided by 1/8 would give us then this 18. So I actually can just type that into the calculator as is. Or again, you could type in this problem, 34 times 9/17. 34 times then alpha F1, and just type in this 9/17, 9/17. That should give us the same answer. So it does is give us this 18 applications. So notice by using estimation and changing the 1/8 to a number that I could understand, this helped me understand that this is a division problem. And then once I understood it as a division problem, I can then translate this back into some math that I can work with by hand or using a calculator. So hopefully you find that helpful.